This multi-frame set is made up of F0 to F15, collectively termed as 16 frames. So by processing these 16 frames only, you will be able to establish the route of calls for all the 30 users. 30 users can be linked. This collective set is called alignment signal. Multi-frame alignment signal bit pattern will be, what will be the bit pattern here? 0, 0, 0. This is MFAS, this is non-MFAS. Once the system receives all 4 digits as 0, in the 16th time slot, it will understand this is the start of the frame set. Right? So, this is the F0 frame. In the sequence of communication, there will be collectively so many multi-frame sets traveling from the transmitter end to the receiver. So, where it will come to analyze when it has to start the count from 0. எங்க இருந்து ஆரம்பிக்கணும்ங்கறத வந்து அந்த ambiguity clear பண்றதுக்காக சிஸ்டத்துல we are using this MFAS. So it will start counting the frames here onwards, and in F1 frame you will be having, instead of in TS0 FAS, the alarm or supervisory. Alarm means, suppose in your transmission line at the exchange side there is no power, suddenly there is a problem in the line has broken down. That will be intimated to the transmitter. நீங்க வந்து பேசிட்டே இருப்பீங்க இல்லனா உங்களுக்கு தெரியாது அதர் end வந்து லைன்ல இருக்கறாங்களா இல்லையாங்கறது எப்படி தெரியும்? பிரேக் ஆயிடுச்சுனா அங்க டெட் ஆயிரும் லைன். That line has to be dump terminal at that time. So for making that, there will be some transmissions all ones. We call it as all ones transmission. When there is all ones alarm, it is an urgent alarm. All ones is always termed as urgent alarm. Once this sequence is received, it will stop the transmission. Supposing that there is a failure in the transmission medium, that will be sent through the TS0 of the frame 1. So all the frames which are in the odd concept will be carrying the alarm or supervisory signal. It supervises the line status, right? And the TS16 will carry the signaling of user 1 and 16. Then in frame F2 again, TS0 is going to carry FAS, TS16 for signaling of 2 and 17, second user and 17th user. And in F3 again, so all the odd frames will carry the alarm or supervisory, and the even frames will carry the frame alignment signal. Okay? You are able to understand? So this is the sequence how the frames are arranged in a frame set. This total frame set of 16 frames is being transmitted simultaneously, and pictorially that is being shown here. So this is holding the frame synchronization, 16 times the signaling. Rest is used for carrying the speech samples. For 15 users one group, another 15 users second group. One of the users from this set and this set will be given the 4 bits allocation in this signaling channel. So this is multi-frame alignment signal, pattern 4 zeros, XY XS is a non-multi-frame alignment signal pattern. It can hold any 0 or 1 value. Accordingly, there will be some understanding. Combination of zeros and ones will represent a particular problem which is being present in the prevailing in this transmission medium. So the set of 16 frames will be similarly arranged. Suppose you take a frame 4, what will be frame 4? It is an even frame, you will have the FAS again. Time slot will hold 2 4 bits for user 4 as well as user 20. 20 in the second. So frame 0, already I have told. Similarly, this is for frame 1, then frame 2, frame 3, frame 4, like that. Last frame, 15th frame, F15, will be holding the signaling of user channel 15 and 30. So, this is the frame 15. This is the shown. In general, a PCM transmission system can be represented in a block diagram like this, where you have a band limited filter at the entry point. Input is analog. Band limited analog signal is sent to the codecs. In the codec, you have the PCM transmitter A to B conversion part. It uses an instantaneous sampling and hold circuit. Sample and hold circuit forward the flat top PAM signal to the next stage of quantization, where it is using M levels. Then the quantized PAM signal is taken to the encoder for conversion to binary. Then we have the PCM signal. This is the channel, transmission medium between two exchanges, between two different locations. You have the transmission wire. Within the wire, how long it can be traveled? இப்போ ரெண்டு எக்ஸ்சேஞ்ச் இருக்குது. ஒன்று வந்து இங்கே நீங்கள் ஆவடியில் இருக்கிறீங்க, இன்னொன்று வந்து நுங்கம்பாக்கத்தில் இருக்கு. டிஸ்டன்ஸ் ஜாஸ்தி. அவ்வளோ தூரத்துக்கு உங்களால் வந்து சர்வீஸ் கொடுக்க முடியுமா? Attenuation or bit error rate may increase. As the signal is accomplished through a longer distance, it undergoes more number of discrepancies, signal discrepancies. So we have to reduce the noise and amplify the signal. So reduction in noise and boosting of the signal alone is done by a repeater, regenerative repeater. We call it as a regenerative repeater. சாதாரண ஆம்ப்ளிஃபையர் போட்டீங்கன்னா நாய்ஸும் சேர்ந்து பூஸ்ட் ஆகும். ஆம்ப்ளிஃபையர் போடக்கூடாது. இந்த இடத்துல என்ன யூஸ் பண்ணும்? ரிப்பீட்டர்னு சொல்லுவாங்க. அது என்ன பண்ணும்? இட் வில் ரீஜெனரேட் தி சிக்னல். ஸ்பீச் சிக்னலை திருப்பி ரீஜெனரேட் பண்ணி அதை மட்டும் பூஸ்ட் பண்ணும். ஸோ அதனால தான் ரீஜெனரேட்டிவ் ரிப்பீட்டர் பேர். இந்த சேனல் ஆர் இந்த மீடியா, இந்த வயர் கனெக்ஷன் 25 கிலோமீட்டர், 20 to 25 kilometers in between, you need one repeater. Right? If it is going to be a coaxial cable. பழைய காலத்து கோஆக்சியல் கேபிள்னா 20 இருந்து 25 கிலோமீட்டருக்கு ஒரு ரீஜெனரேட்டிவ் ரிப்பீட்டர் ஸ்டேஷன், அங்கே ஆம்ப்ளிஃபிகேஷனுக்காக ஒரு யூனிட் வச்சிருப்பாங்க. ஆம்ப்ளிஃபை பண்ணதுக்கப்புறம் இட் வில் பி ரீட்ரான்ஸ்மிட்டட் அன்டில் இட் ரீச்சஸ் தி டெஸ்டினேஷன். சோர்ஸில் இருந்து டெஸ்டினேஷன் வந்து 10 கிலோமீட்டருக்குள்ளே 10 மீட்டருக்குள்ளேயே இருக்கலாம், பக்கத்திலே இருக்கிற வீடாக இருக்கலாம். நீங்கள் கூப்பிடுற ஆள் வந்து ஆயிரக்கணக்கான கிலோமீட்டர் தள்ளியும் இருக்கலாம். So, அவ்வளோ தூரத்துக்கு இந்த சிக்னல் வந்து வீக் ஆகாமல் ட்ராவல் பண்ணணும்னா you need regenerative repeaters. Every 25 kilometers it is implemented. In the case of a coaxial cable, if it is going to be an optical fiber cable, we use every 70 kilometers because fiber has a long span of working. Fiberல வந்து it is a dielectric media, so you will be having more amount of enhanced space for traveling. There will not be much of the interference. So, intersimple interference, EMI, everything is controlled in a fiber. You will be operating the fiber for up to 70 to 80 kilometers without regeneration. And at the receive side, at the destination point, this is undergoing one entry point itself. You give some amplification to the signal. Later on, you apply the decoding process, demodulation and decoding. Whatever carrier you have used, that carrier is being demodulated and removed. Later on, the decoded information from binary to back to decimal. And finally, reconstruction of the signal. Resynthesis or reconstruction of the signal takes place so that you will be arriving at the original analog signal at the equipment, user equipment. So this is the PCM transmission system. Right, next matter. Frame duration is 125. You are going to send how many 8 bits? 8000 samples. This is going to basic bit rate. So 32 into 125K. going to be the data rate, bit rate of PCM. For sending all the 16 frames, 16 into number of bits per frame. In one frame there is 32 time slot, each time slot is 8 bits. 256 bits per frame. So 16 into 256, which is nothing but 2 milliseconds. This is the frame duration for a multi-frame set. Line coding. What do you mean by line coding? Line coding is converting a string of ones and zeros into a sequence of signals that denote the ones and zeros. You have to give some representation, voltage representation for putting it in the form of a pulse waveform. 0 has to be represented in a pulse waveform. Similarly, 1 also has to be represented. So, for example, a high voltage level plus 3 volt could represent a logical 1, and a low voltage level is used to represent a logical 0. Then we could represent it in the form of, instead of putting a 1, we are sending plus 5 only. Instead of 0, we can send either 0 volt or minus 1. So a string of ones and zeros, if you have, you will be having, this is the timeline, plus V and minus V. 1 will be represented by a plus V voltage and 0 by a minus V voltage. Again 1 plus V minus V. There is no transition here. Everywhere you will be having a continuous signal. So what for line coding is done? To match the characteristics of the transmission medium, we are converting the bit sequence into a pulse waveform. So this pulse should be free from DC component. There should be, it will lead to attenuation, and in the near end problem it is crosstalk. Low frequencies will contribute to crosstalk. So this crosstalk and attenuation has to be reduced as far as possible. So in selection of line coding, we have to take care of all these factors. And one more major thing is the total bandwidth occupied should not exceed beyond a certain limit. So total bandwidth should be as small as possible. ஒரு gift உங்க ஃப்ரெண்டுக்கு நீங்க அனுப்ப நினைக்கிறீங்க, நீங்க போஸ்ட் ஆபீஸ்ல கொடுக்கும்போது அதுக்கு லேயரா ப்ரொடெக்ஷன் கொடுக்குறீங்க, பேக்கிங்கே நிறைய போயிடுச்சு, உள்ள இருக்கிற விஷயம் கம்மியான வெயிட், பேக்கிங் தான் அதை விட 3 மடங்கு 10 மடங்கு அதிகமாகுதுன்னா சார்ஜ் எவ்வளோ ஆகும்? 10 ரூபாயில அனுப்புற விஷயத்துக்கு 100 ரூபாய் ஸ்பெண்ட் பண்ணிட்டு இருக்கீங்க. அந்த பொருள் அங்கே போய் 10 ரூபா வாங்குற, 10 ரூபா போட்டால் கிடைக்கக்கூடிய பொருளுக்கு 100 ரூபாய் செலவு பண்ணுவீங்க. இஸ் இட் a effective way of communication? அதுதான். Overhead bits should not increase beyond a certain limit. So payload is only 50%. You are applying more than 50% for the security of that payload. That is not an effective utilization of the bandwidth. So the bandwidth should be chosen as small as possible. Accordingly, the line code will be selected. Right? So line code has to accomplish all these factors into consideration. After the encoder are sent through the transmission channel in the form of pulses like this at the trans side, source side, at the receive side, destination side also. It is used certain frequencies மட்டும் அதுல பெர்மிட் பண்ணும் உள்ள போறதுக்கு. அப்போ மற்ற frequencies வந்து allow பண்ணாது. So low frequencies accumulation வந்து avoid பண்றதுக்காக we are controlling the DC. That is what is line code. Second point is self-synchronization. Timing regularly should be possible every time. You should provide as much of transitions. நிறைய transition கொடுத்தானா clock recovery வந்து ஈஸியா continuous ones அல்ல zeros வர இடத்துல transitionே வரலன்னா எப்படி நீங்க எங்க இருந்து ஸ்டார்ட் ஆகுது இது வந்து presence of signal இல்ல idle time ஆங்கிறது differentiate பண்ண முடியாது. So that is why the clocks at the sender and the receiver must have the same bit interval. Bit interval should be appropriate. So the receiver clock is faster or slower. As the receiver clock idu match agalena, you will be having mismatch interrupts. You will be utilizing for incoming bit stream. Adoda pada eppdigiradha madam. As sent to receiver odadum match agadappa ungalku theriyala difference is time lag எல்லாமே வந்து டிஃபர் ஆகும். ஒரே டைம்ல சின்க்ரனைஸ்டா கிடைக்காதப்ப என்ன ஆன் ஆஃப் பீரியட்ஸ் will be overlapping each other. எந்த இடத்துல முடியுமோ அந்த முடியலனா ஆஃப் பீரியட் ஆன் பீரியட் will overlap, they will lead to aliasing effect. Aliasingங்கிறது வந்து it is an unwanted factor. 0 and 1 will not be predominant. Error detection. Error வந்து கண்ட்ரோல் பண்ணனும்னா முதல்ல எங்க எரர் இருக்குங்கறத கண்டுபிடிக்கணும். So that is being done during transmission by some impairment. We are considering certain techniques, and the techniques are some codes are constructed such that when an error occurs, it can be detected. For example, a particular signal transition is not part of the code. உங்களுக்கு இந்த சீக்வென்ஸ் வந்து இதுல அனுப்பவே இல்லை, நீங்க ஒரு பொருள் அனுப்பவே இல்லைன்னு உறுதியா தெரியும் போது அது உங்களுக்கு கிடைச்சிருச்சுன்னு ரிப்ளை வந்துச்சுன்னா நீங்க நம்புவீங்களா? நான் ஒரு விஷயத்தை செய்யவே இல்லை ஆனா எனக்கு நீங்க யூ ஆர் செலக்டட் அப்படி நான் வந்து அங்க போய் voting பண்ணவே இல்லை, போலிங்கே பண்ணல, பட் யூ ஆர் செலக்டட்னு சொல்லிட்டு யூ ஆர் கிவன் சம் பிரைஸ் கிஃப்ட் SMS வருது. உங்களோட டேட்டாவை நீங்களே பிரசன்ட் பண்ணாதப்ப when you are not presented a query, you are getting a response, you will not rely upon it. Similar way here also it occurs. The receiver will know that a simple error has occurred, some error has been feed into it. Certain bit patterns which are not permissible, if they come across such bit patterns, they will reject. Noise and interference. In line coding, there are techniques that make you use of the transmitted signal which is immune to the noise and interferences. This means that the signal cannot be corrupted. It is stronger than the error detection. எல்லாம் ஏற்கனவே டீல் பண்ணதான் போர்டில் சொன்னதான் அந்த. ஸோ டிஃபரெண்ட் லைன் கோடிங் ஸ்கீம்ஸ்ல வந்து என்னென்ன லைன் கோட் பண்ணதுக்கப்புறம் லைன் கோடிங் ஸ்கீம்ஸ் எல்லாம் இன்வால்வ் ஆகிடுச்சு. திஸ் லைன் கோட்ஸ் will incorporate any one of these schemes. Either it can be unipolar or a polar type or a bipolar type, or it can be a multi-level or a multi-transition coding system. If it is going to be unipolar, it comes under non-return to zero. Non-return to zero category. In polar you have non-return to zero as well as return to zero type, and bipolar Manchester and differential Manchesters. In bipolar you have two types, AMI and differential AMI. That is opposite of AMI is pseudo ternary. In multi-level, instead of sending 2 bits, it is being modified into 1Q, 2B 1Q or 8B 60 or 4D fab 5. In multi-transition, one example is MLT. Coding schemes. And again, what is NRZ? Non-return to scheme is an example of this code, where the signal level does not return to zero level at all. Either it will be lying in the above the time axis or below the time axis. Either the signal will be like this or it will be like this. Nowhere it is returning to zero. So the scheme is prone to baseline monitoring and DC components. It has no synchronization at all. So what all should not be there, everything is within this, inherently within this NRZ coding. So this cannot be used for line codes. From this only, rest of the things emerge. That is why NRZ is taken as the basic. Error detection is also not possible, and it is simply but costly in power consumption. Next. Here, this is one type of NRZ code, unipolar NRZ code. Okay, one bit is represented by positive V and 0 bit the signal like this. Whenever you have continuous ones, you have accumulation of DC. So the power spectral density, if you look at the power spectral density, it is contributed by half V square. Normal power will be always, there will be some DC component. So next to take polar, in polar R is return to 0 form. If you have no DC components or baseline matrix, so self-synchronization timing is incorporated in this. It indicates simple value. More complex as it uses 3 voltage levels. Here using 3 voltage levels, we are able to, it has no error detection capability. We are able to recover the timing, but not the correction of errors. So this scheme has more signal transmissions, 2 per symbol, and the rest of the time will be like this. Next. In R is return to 0, for representing a 1 bit, 50% of the duty cycle, it will be lying in the plus 5 volt or plus 3 volt. Rest of the time it will come to 0 volt. Then again 0 is represented by 0. Next 1 bit, if you have another 1 bit, 50% of duty cycle it will be in V plus and 50% in 0. Again 1 bit. Here more number of transitions are permitted. So clock recovery is easy, is possible. Even then it cannot be used for, you cannot reduce the DC component. It occupies more bandwidth because it uses more number of simple rates. See, look at for 0, this, for 1, again 0, minus P volt, plus P volt. The transition from minus V volt, again minus V volt. This is plus V. More number of transitions are involved, so clock recovery is possible. But bandwidth, if you look at the bandwidth in the power spectral density, it will be twice the bandwidth as in NRS. 2 bits are used for representing a single symbol. And bipolar AMI, and this AMI is derived from RZ. Suppose we have a string of 8 bits like this. In AMI, this is going to be the time 0, minus B plus B. 1 bit will be like this, again 0, again 1 bit. Next to mark bit will be minus. Alternate marks will be inverted. That is alternate mark inverted. Next to 1 bit, again it will be like this. So this 1 bit will be inverted. 0, then again 1 bit. Like this. This is going to be AMI code. So voltage level for one symbol is at 0. 0 is 0. And 1 bit, mark bit, other alternates between plus and minus. Plus V and minus V. So bipolar alternate configuration. The 0 symbol is represented by a 0 voltage and 1 symbol is alternate plus and minus. Pseudo ternary is the reverse of AM. Pseudo ternary case, for 0 volt it will be reverting. Alternate bits will be reverting, inverted. And 1 bit will be 0. And bipolar codes will have some more. It is a better alternative to NRZ. NRZ total line code is like RZ is better. But even in RZ again we are coming across bandwidth problems. So we have modified RZ forms, modified bipolar. We are giving both the sides polarity in AMI. Later on this AMI is capable, it has no DC component or baseline monitoring. What is meant by baseline monitoring? Monitoring means not within the limitations. Trade-offs illama power spectral density எடுத்து பாத்தீங்கன்னா இதுதான் side bands components வந்து நிறைய போயிட்டே இருக்கு. So has no self synchronization because long runs of zeros results in the no signal transmissions. So no error detection at all. Representing the multi-level codes, multi-levels, various levels of L is represented by binary, ternary. Binary means 2. Ternary means 3. Quaternary means 4. Quadrature. In QAM also you would have come across quadrature, amplitude modulation, 4 phases, phase shifts. Similarly here also we are using quaternary for 4. So the general notation here is MBNL, that M represents the number of binary bit patterns, the length of the binary bit pattern, and B represents the binary data, and N represents the signal pattern. Binary pattern is different, the signal pattern is different. Within a signal pattern there can be more number of binary data. So number of bits, bit rate and baud rate is different. Symbol and baud rate is same. And L is the number of levels. In general notation we call it as MBNL scheme. So in pictorial representation we have for 2 bits 0 0 1 1 0 1 1 0. That is you are giving with respect to the previous level. The previous level is positive, starting with in the ternary scheme +1 +3 -1 -3. For these bit patterns, corresponding levels of voltages that can be represented in the pulse mode. If the previous level is going to be negative, so first என்ன பண்ணுவீங்க 0 0ங்கிறது வந்து இங்க 0 0ல previous bit வந்து பாசிட்டிவ்னு எடுத்துட்டு +1 கொடுக்குறீங்க. இது பாசிட்டிவா இருக்கிறதுனால previous bit, next bit pattern 11 1 1 can be, if it is represented in previous positive la 1 1 la என்னன்னு பார்த்தா -3. So இங்க இருந்து -3 க்கு கொண்டு வந்தாங்க. இங்க வரைக்கும் வந்தது. அடுத்த bit pattern previous bit pattern பேஸ் பண்ணி previous bit pattern -3 ன்னு வந்துருச்சு. அப்போ previous நெகட்டிவ்ல எடுத்துக்கலாம். நெகட்டிவ்ல இந்த 0 1 க்கு கரஸ்பாண்டிங்கா என்ன? -3. Again -3. Next bit pattern 1 0. 1 0 based on previous negative +1. So it should be brought to +1. Right? Then 0 1 is again going to be based on the previous is positive +3. So you are pulling it to +3. So this is going to be the representation based on this truth table. For various bit pattern combinations, what should be the levels? So the levels will depend upon the previous bit, whether it is positive or negative. MBNL bit pattern and signal pattern. So this is monitoring phase. Next. Proceeding either in the +4 or -3 according to this diagram is drawn. So MLT3 is a signal rate is same as NRSF. In NRSF you have 2 types. One is L. NRSF L is level. And NRSF I is inversion. This is NRSF I. Because of the resulting bit pattern, we have a periodic signal for the worst case bit pattern. So whenever there are continuous ones, then it is considered to be a worst case. can be approximated as an analog signal frequency for 1/4 of a bit. So in general, this is the summary of the line analysis for the summary of. So majorly what we are using in telecommunication, AMI codes are used as line codes for American standards. North American and Japan standards are making use of AMI for their line code. And European standard is using a modified version of the AMI. Modified version of the AMI is called HDV3, high density bipolar of order 3, HDV3 codes. They are belonging to a family of BNZS family. Binary N0 substitution. Whenever you come across a continuous sequence of 0 bits, there you will not be able to recover the timing. Synchronization cannot be taken. For that purpose, what they are doing, they are voluntarily introducing a violation bit. This violation bit will be following certain rules. So HDV3 group is also called as V4ZS because it permits up to 3 zeros continuously. Beyond the third zero, if there is a fourth zero appearing, the violation bit will be introduced based on a particular rule. That rule is, with this it will be coming to an end. I'll just state this rule. Previous mark bit, 1 bit. If it is going to be number of 1 bits, odd or even. Sorry, positive, negative, then here I'll take odd and odd. We are following this rule. And if it is negative, we are following this rule. The fourth zero will be replaced by V plus. Whenever there is a string of 4 zeros appearing, for getting the clock recovery possibility, we have to introduce some violation rule. That rule is called HDV3. This permits only 3 zeros. The fourth zero will be V plus. If it is positive, previous 1 bit is positive, this is V plus. If the previous 1 bit is negative, this is negative, V minus. And if there are even number of 1 bits preceding this code, preceding this sequence of 4 zeros, if our number of ones is even, then the violation rule will be bipolar violation rule, B00B. If this is positive, this is negative. If this is negative, this is positive. This is bipolar violation, this is violation. So implementing this rule is called HDV3. So this is called as modified AMI line code, where this modified AMI is used as a line code in the European standards, E1 standard. Next. So coming to now, after line codes, line coding schemes and block codes, wherever you come across radio signals, block code, convolutional codes are used. Block code means what? It involves 3 stages. One is division, then substitution, then combining. You have a string of 8 bits as input. This 5 bits will be segregated like this. 5 plus 3. This 8-bit group is first divided. Division will take place. Then this will be converted by substitution into a 6-bit code. And this will be converted to 4-bit. So 5 will become 6, 3 will become 4. 6 plus 4, totally 10 bits. So instead of 8 bits, you will be having 10 bits. 8 bit, 10 bit. code. Combining these 10 bits, the third process will take place. So this now becomes a block. In a group of zeros and ones binary data, we are segregating 5 bits one time and another 3 bits one time. You are expanding or including redundancy. Redundancy is included for what purpose? For error detection and correction. This enables error detection and correction. When there are unusual combination of zeros and ones appearing in a particular stream at the receiver, it will identify it as an error and it will reject that particular string. That is the purpose of block code. Scrambling. Scrambling is nothing but more amount of bit stuffing, again for error correction. Here again you are going for self-clocking. You are introducing more transitions so that you will be able to synchronize the receiver. No low frequencies are permitted here and no void bandwidth. Bandwidth occupation is very, very reduced when compared to the block codes. So it is implemented at the same time as encoding. The bit stream is created in the flight. So it replaces unfriendly run of bits with a violation code. Whenever continuous zeros, 8 zeros is coming, what it will do? It will segregate into 2 groups and then it will apply the HTTP rule. And it is easy to recognize and remove the unfriendly code. Unfriendly means nothing but string of continuous zeros. For example, suppose this is going to be a consecutive one. It will apply 0, 0. Previous one is positive. Negative rule here. Again, after application of a particular violation rule, you have to start from here. Count the number of 1 bits. 0, 1 bits. So even rule. Even rule will include the bipolar form of violation. So bipolar violation will be like this. B00B. V plus 0, 0. This is 0, 0, V minus. So two violations, different violations are, you should not count this one here. For considering this place, after the violation bit, how many 1 bits are there? Then only you should apply the violation. Violated digital signal, modified AI by encoding substitution, 0 substitution. First 2 bits are 1 bits. 2 means even. 2 1 bits are there. Even number of mark bits. Then 4 zeros are coming. So even number means you will apply B00V rule. Bipolar violation rule. Where B00V is given this polarity by based on the previous 1 bit. Previous 1 bit is negative, this becomes positive. This is positive, this is also positive. Right? According to our rule table I have given. Then 1 bit is appearing here. If the violation bit is positive, the next 1 bit will be negative. So always you are alternating the 1 bit so that accumulation of DC is avoided. Transitions are provided in the continuous 0 places.